Next, let's solve question number 3. Question number 3 says that prove that the following are irrationals. We are going to prove the following as irrationals. Roman number 1 is given with 1 divided by root over 2. Okay, let's solve it. First, we will assume the opposite, that is 1 by root over 2 is rational. Then we will prove that our assumption is wrong. Okay, let's first assume it. Let us assume the opposite, that is 1 by root over 2 is rational. Hence, this 1 by root over 2, if this is rational, then 1 by 2 can be written in the form a by b, where a by b are coprimes, where a and b are coprimes. Hence, 1 by root over 2 can be written in the form a by b, where a and b, here b must not be equal to 0, are coprime. Here coprime means no common factor other than 1. No common factor other than 1. Hence, this 1 by root over 2 will be equal to a by b. Hence, 1 by root over 2 will be equal to a by b. Transporting, we get, taking reciprocal, we get root over 2 is equal to b by a. Here b by a is a rational, but here root over 2 is an irrational number. Here b by a is a rational number, but here root over 2 is an irrational number. Is an irrational number, since we know that rational is not equal to irrational. Since rational is not equal to irrational, so there arises a contradiction. So our assumption is wrong. This is a contradiction. This is a contradiction. Our assumption is wrong. Hence, 1 by root over 2 is an irrational. Here it finished the Roman number 1. Next, let's solve Roman number 2. We will be solving this 7 root over 5 as an irrational number. First, let us assume the opposite, that is 7 root over 5 be a rational number. Let us assume the opposite, that is 7 root over 5 is rational. If this is rational, then 7 root over 5 will be can be written in the form a by b. Hence, 7 root over 5 can be written in the form a by b, where this a and b are co-prime, where a and b, here b must not be equal to 0, are co-prime. Co-prime means no common factor other than 1. Other than 1. Hence, this 7 row of 5 will be equal to a by b. 7 row of 5 will be equal to a by b. Transporting, we get a divided by 7b. Here, a divided by 7b is a rational, but this row of 5 is an irrational number. Here, a divided by 7b is a rational number, but this row of 5 is irrational. Since we know that rational is not equal to irrational, there arises a contradiction. Since rational is not equal to irrational, this is a contradiction. So our assumption is wrong. So our assumption is wrong. Hence, we can say that 7 row of 5 is irrational. Here we finish Roman number 2. Then next solve Roman number 3. Roman number 3, here we are given with 6 plus root over 2. We are going to prove that this 6 plus root over 2 is an irrational. First, let us assume the opposite. Let us assume the opposite, that is 6 plus root over 2 is rational. Hence, if this 6 plus root over 2 is rational, then we can be written in the form of a by b. 6 plus root over 2 can be written in the form a by b, where this a and a b are co-prime, where a and a b, here this b must not be equal to 0, are co-prime. Here co-prime means no common factor other than 1. No common factor other than 1. Hence, this 6 plus root over 2 will be equal to a by b. 6 plus root over 2 will be equal to a by b. Transporting, we get root over 2 equal to a by b minus 6. Here a by b minus 6 is a rational number, but here root over 2 is a rational number. Here a by b minus 6. This part is a rational number and this part is an irrational number. We know that rational is not equal to irrational, so there arises a contradiction. A by b minus 6 is a rational number, but here our root over 2 is a irrational number, but root over 2 is irrational. since we know that rational is not equal to irrational. Rational is not equal to irrational. There arises a contradiction. Where this contradiction arises? This contradiction arises from our own very assumption that 6 plus over 2 is rational. This is a contradiction. So our assumption is incorrect. So we can conclude that 6 plus root over 2 is irrational. With these questions, we conclude the chapter number 1. Here we had completed all the chapter number 1 questions. See you in my next video.